This is the inclined plane problem. The Johnston Inclined Plane in Pennsylvania is one of the longest and steepest hoists in the world. The railway cars travel a distance of 896.5 feet at an angle of approximately 35.4 degrees, rising to a height of 1,693.5 feet above sea level. So I'm going to draw a picture that shows you what's going on. That's a little bit dramatic. 35.4 degrees is maybe something like that. Even that's probably a bit dramatic. There. I feel better with that one, right there. 35.4 degrees. So they've got this incline. So here's our incline. And the railway trains, the cars, they travel along this incline. And when they get to the top of the incline, when they get to the very top of the incline, they're going to be 1,693.5 feet above sea level. Now in Pennsylvania, you're not at the ocean. So this point right here is not zero sea level. So this is not sea level right here. So they're already sitting above sea level somewhere. Sea level is going to be, I don't know, somewhere down here. So that's where sea level is. So this is going to be some number already above sea level. So this is already above sea level. And specifically, when these cars get to the top, they're going to be 1,693.5 feet above sea level. So their 1,693.5 feet is not only the height of this incline, but it also includes the distance from sea level to the ground. Now, when they travel a distance of 895.5 feet. So this number right here is 896.5 feet. So there's a picture of what's happening. We want to find the vertical rise of the inclined plane. So the vertical rise is going to be that vertical distance, that vertical rise of the inclined plane. So I'm going to call it y. So the trig function I'm going to use, this is the opposite, and this is the hypotenuse. Opposite hypotenuse would be sine. So that would be the sine of 35.4 degrees is equal to y over 896.5. I'm going to multiply both sides by 896.5. No, not tangent, sine. 35.4 degrees. So I put this into my calculator, and I'm going to get that approximate vertical rise from the bottom of the incline to the top of the incline. So I put this in my calculator. I'm going to have 896.5 times the sine of 35.4 degrees, and I'm in degree mode. So that's about 519.326 feet. So this distance, this length right here, is about 519.326 feet. Well, we want to, let's write that down, 519.326 feet. So that answers that question. We want to find the elevation. So what's the elevation? So the elevation when we get to the top is 1693.5. Well, that's after we traveled 519.326 feet. So I'm going to take that 519.326 feet away, and I'm going to get the elevation that we started with. So our elevation is going to be 1693.5 minus that value right there. So minus the 519.326. But I'm not going to put 519.326 in my calculator. I'm going to actually store it and then subtract later. So I'll show you what I'm going to do. There's a couple of different ways that we can do this. But storing is always a good practice to know. So I'm going to hit store, and then I'm just going to store it as alpha A. Enter. And now I'm going to take that 1693.5, was that 1693.5? 1693.5 feet. 1693.5. I'm really not going back to the other page, and I'm trying to remember 1693.5. You're probably going, yes, I can see it on my paper. It's 1693.5 minus that stored value, alpha A, and that gives us 1174.174. Now there's another way to do this without storing. 1174, I'll show you that in a minute. So this value right here is going to be 1174.174 feet above sea level. So that's where we started. That was our elevation before the cars started up this incline. So before those cars started up the incline, the elevation, wherever they are, is 1,174.174 feet above sea level. And that's called your elevation. Now the cars move up the mountain at a rate, I don't know if it's a mountain or it's up the incline. They travel or they move up that incline at a rate of 300 feet per minute. So let's take a look at this picture. So this is almost 900 feet. They're traveling 300 feet in 1 minute. So 300, 300, about 300. It's taking them just a little less. So sorry, it's taking them just a little less than 3 minutes to get all the way up. So I'm going to draw a picture. I'm going to try and draw something here that you can relate to. It's red. So I'm going to say that this is 300. So they're traveling 300 feet in 1 minute. What is their vertical? What is their vertical rise per minute? So if they're traveling 300 feet per minute, what is the vertical rise? This would be your vertical rise in feet per minute. Well, if I need to find that green side, I've got the opposite. That's my opposite side. I've got the hypotenuse of 300. That's going to be the sine function. I'm going to have the sine of 35.4 degrees. So I'm going to have the sine of this angle right here is equal to this vertical rise over 300. So I'm going to just say the vertical, I'll just call this x over 300. I'm going to multiply both sides by 300. And I'm going to put that into my calculator. 300 times the sine of 35.4. And I get approximately 173.784 feet per minute. Because remember, that's what we were measuring. It was not 300, it was 300 feet per minute. So when I multiply both sides by 300, I'm multiplying it by 300 feet per minute, and that's what x is going to equal, the feet per minute. That concludes this video and the notes of word problems involving trig functions. So we completed a pretty simple problem, which many of our problems are simple and can be solved with one right triangle. We solved a little bit more complicated where we needed to use our algebra skills of solving a system of equations and then substituting back in one value for the other. And then we solved this problem that talked about not just elevation in the real world, but it also talked about what's the rate at which they rise vertically. So that's something too we were able to compare to. I hope you were able to make sense of the video, and that you have good luck in your future endeavors in math.